Okay, dear students, today's topic I'll be going on primitive network. In previous videos, I have gone for this introduction section of load flow studies regarding network and what is this incidence matrix, as well as bus incidence as well as node incidence matrix we've gone through. So now I'll be going for primitive network, and this is one question will be there. They'll be asking like this: define a primitive network, explain with a neat sketch its equations, circuit equations, and the significance of each in both the impedance and admittance form. So you have to form the network and you have to form the equations in terms of impedance admittance form and obtain the performance equation in both. Okay, significance along with that performance equation you have to write. So 6 marks question they will be asking this one. So what is this primitive element? So this is a fundamental element which is not connected to any other element. Okay, so this element is independent, it is not connected to any other element, or you can define as a set of unconnected element is defined as primitive network. Unconnected. Okay, the network elements which are there, these are all unconnected. So elements are not connected to any other. So all independent elements will be there. Okay, so primitive element is a fundamental element which is not connected to any other element. For example, if you form a Y bus, so in that Y11, Y12, whatever will be there, so these are all individual. Okay, individual elements we are forming here. So individual elements nothing but primitive element. It is a fundamental element which is not connected to any other element. A set of such unconnected element is defined as primitive network, and the network components represented in both impedance and admittance form. So now we will be forming here different variables and parameters, and one thing I wanted to show here as what you people have done, and for Vinta madam have sent this diagram. Okay, in primitive network both are same only, should not get confused. Okay, whichever you can refer, either this or that. So this one and this one I am taking from stack book. Okay, standard book, whatever I am showing here, this diagram, this is from standard book, that is stack book. Okay, same, whichever you can refer, you should not get confused. So that's why both diagram I am showing here, so you should not get confused. So this is the impedance form, this is the admittance form. So now I will be taking the same diagram, I will redraw, just you draw in horizontally, same thing you draw in horizontal form, just bend it. Okay, say both are same only, and notation they are taking in terms of RS, like that. I will be taking here in terms of PQ. Okay, notation it may change, but equation remains same only. Okay, I will be considering, I am referring here stack book. So here they are referred Umara book, whichever they can refer, both are same only. So now I will be explaining mine here. So notation I am taking EPQ, voltage with respect to PQ. PQ nothing but nodes here. In between PQ nodes, what is that voltage? Okay, this is the impedance form. Okay, so here this impedance form I will be writing in terms of what you will be getting here, impedance. So impedance, so this is the impedance and two nodes P and Q, this is the voltage EP and EQ. So reference I have given, what is this VPQ, voltage across the elements P to Q, EPQ, source voltage in series with element PQ, and IPQ, current through element PQ, JPQ, source current in parallel with element PQ, and ZPQ is the self impedance of the element PQ. YPQ is the self admittance of the element PQ. Okay, so using these elements, now we'll go for, see, check it, what is this performance equation. Each element has two variables. What are those variables? Voltage and current. Obviously, these are the variables, voltage and current, which will change here. And in steady state operation, so the parameters of the elements, whatever the parameters of the elements here, impedance and admittance are the parameters, and V and I are the variables. And these impedance elements are the real numbers, direct current circuits. Okay, and complex numbers of alternating current. So direct current circuit DC as well as complex number for alternating currents. So these values, impedance and admittance values for DC as well as AC, it will differ. Direct will be there, these values for DC with DC circuits, whereas if you consider for AC, so there you will be getting complex term. Obviously, if you take power like P plus JQ, so the J is the complex term you will be getting in AC. So what is this primitive network? Primitive network, primitive element is a fundamental element which is not connected to any other element. So set of unconnected element called as primitive network. Okay. So now I will be taking these two. So here you will be forming this impedance form, this is admittance form, And then in this impedance form, here two nodes P and Q, in between current source, and this is impedance, and current is flowing here IPQ. So what is here? Voltage will be EP minus EQ. And here also I will be considering two nodes, and this is the current junction, current source. Here here one current is flowing, here also I will be taking, actually here I am not showing here. Here IPQ flow will be there. This is IPQ and this is JPQ. Okay, both current you have to take here IPQ plus JPQ. Okay, the flow will be like this. Okay, here JPQ and here this, in this they are taken as IPQ. Two currents. What is this JPQ? Source current in parallel with element. Okay, and this is the current through element PQ. Current through element PQ is IPQ, and this is the parallel element JPQ. Both you have to add. So now I will be taking in terms of admittance form. Okay, so now they have represented the same. Now we have to write in terms of equation. Okay, now VPQ plus EPQ. VPQ is the voltage, VPQ, and this is the voltage. Both voltage you add. VPQ plus EPQ. This voltage is equals to, and this you know, V is equals to Z into I. Starting itself in class I told, V is Z into I. What about I? I is Y into V. These are all relationship between current and voltage in terms of impedance admittance form. So V is equals to Z into I, what I discussed previous. Okay, V is nothing but total voltage. What is this total voltage here? VPQ and EPQ. Okay. So therefore VPQ, EPQ, that is equals to ZPQ and IPQ. Okay, that is equals to impedance form. Okay, this you can write easily. Here you won't get problem. This is KVL form, because here voltage we are adding. And here in admittance form, here current we are adding. Here voltage we are adding. VPQ plus EPQ is equals to ZPQ, IPQ. Okay, same thing in admittance form. This one current, here KCL we are applying here. So here IPQ and two currents, IPQ and JPQ. So therefore IPQ plus JPQ is equals to YPQ into VPQ. Okay, understood what I am telling? Okay, just have a look this equation. So two voltages, this voltage and these two voltage you add. So total V is equals to Z into I. This you know, and as what you have done in symmetrical PSA1, I bus is equals to Z bus into V bus equals to Z bus into I bus. Same thing here, V is equals to Z into I. V is here total voltage, VPQ and EPQ, and ZPQ is equals to ZPQ into IPQ. This is for KVL we are applying here. We are KCL we are applying. Two currents here, KCL. I is equals to Y into V. IPQ plus JPQ. So therefore IPQ plus JPQ is equals to YPQ and VPQ. Okay, here parallel current source will be JPQ and is related to the series voltage in impedance form. But in short, the same equation we are writing here in another form. This parallel source, if you take JPQ is minus YPQ into EPQ. Actually negative value you will be getting if you take in 1 by if I take. Okay, so just I am writing in this form. No need actually, but you can write like this also. Okay, this is the equation. This is the main two equations, performance equations. And then now I will be writing in another form in terms of matrix form. And the performance equation of primitive network can be derived by expression the variable as vector form. Same equations will be writing in vector form. See. So E, V, whatever variables will be, variables are current and voltage. These are the voltage and these are the currents and current voltage. All these variables, current, voltage, you write in terms of matrix form. Sorry, not matrix, vector form. Remaining all in matrix form. Okay, so now current, voltage. So these are all vector form, and this is matrix form, this is vector form. So these are all variables, vector form, this is matrix form, this is variable form. So now I will be writing performance equation in impedance form, and this is admittance form. So these are the two performance equation of primitive network. Okay, and this is very important, and ZY plays a very important role. This is primitive network impedance, admittance, and if you same impedance admittance can be called as self impedance, self admittance. See, if I take PQ, this Z, if I take PQ comma PQ, that is self impedance. Same thing if you write like YPQ comma PQ, that is self admittance. Okay, PQ PQ self. And same thing if you write like PQ comma RS, different here too, both are same, that is self admittance. Here also same, self, because this is needed in building algorithm. If you write same equation like Z of PQ comma PQ, that is self, same, 1 1. It is just like 1 1. Z of PQ comma PQ nothing but Z of 1 1. Okay. Here if you write Z of PQ comma RS nothing but Z of 1 2. That is nothing but mutual impedance. Okay, so this impedance consisting of self as well as mutual impedance, the values you are getting matrix form, and this is n cross n. The matrix size will be n cross n, and here matrix size will be n cross n. Remaining all matrix size will be n cross 1. Okay, as what I taught in previous class. So this is all about primitive network. So the 6 marks question they are going to ask on this.